Tools. The ultimate proof of professionalism. The fancier and more expensive they are, the more good looking you are. The more you buy, the less of an imposter you become. Every item acquired removes a stain from your very soul. And most importantly, they can save you time. Just like buying gear makes you capable, changing your tools as a programmer makes you competent. What are your tools? What is your stack? What is your soul?
Like any developer with delusions of grandeur, I am constantly revising and revisiting my ideal technical stack for that one revolutionary SaaS I'm gonna build one day. Any day now. But I figured it would maybe be interesting if I froze my ideas of the moment and share them with you for maybe education, maybe amazement, maybe ridicule. Who knows? I figured it could be a good discussion at least. I'm Lars Wikman, and this is Underjord. What I'm into as a developer is influenced by a number of different factors. One major one for the last few years has been my preferred programming language, which is Elixir. It has fundamentally changed what tools and techniques I prefer and the way I think about setting up development projects. With my previous language of choice, Python, it was incredibly impractical to effectively utilize multiple CPU cores. It can be done, but it's not really convenient, it's not very efficient, and it's hard to make robust, so it's not that reliable. Elixir, on the other hand, makes it trivial, very, very easy to apply both concurrency and parallelism inside the Erlang VM that Elixir uses. So this has shifted my thinking away from the idea that you need to be able to build out horizontally scaled to a number of nodes to achieve a fairly high scale and a high degree of concurrency and parallelism. This opens the possibility of using a few or a single dedicated machines that are much, much beefier, or that you scale upwards by upgrading the server instead of building out this multitude. And that can allow a simpler deployment where you don't have to manage a horde of virtual machines and you have much less orchestration and coordination to do between machines. A single machine does not require a lot of coordination. As far as infrastructure goes, I really dislike massive cloud corporations, so I'd rather not use them. And beyond that, I'm based in the EU, and I'd rather not close my eyes and hope for the best, but instead try to show that you can comply with Schrems 2, you can comply with the GDPR, and you can skip being an asshole about it. You can just make it work in a nicer way. So I primarily look at European providers, but I will say when it comes to the type of providers I'm talking about, they are also available in other regions. It's just a matter of moving away from the big ones and considering which ones are actually, I guess, local to you in the sense of jurisdiction or country. Shop local. I've also never really cared for their sort of proprietary special sauce, special infinite scale or serverless services. It's just not the way I like to build things. It's not the kind of dependencies I like to bring in. So none of that for me. This leaves me with using smaller cloud providers or data center operators, such as Elixir, which is a previous sponsor of this channel, and I believe future sponsor as well. And I genuinely like what they do. They're a Swedish company working mostly in the Nordics, and they have a human scale of operation, which means I can get in touch with actual people when I have issues. Look for something like that if you want to sort of match this idea of mine. Or you could go with a provider like Hetzner, which is something I'm definitely looking at as well, because they are extremely price competitive without being this sort of proprietary super cloud. They just provide computers and infrastructure at an efficient scale. I don't know of any company that beats Hetzner's pricing for dedicated machines. So once I have a server available, I would slap a Linux on it. I would probably grab an Ubuntu LTS, so long-term support. I bet there are people out there that will say, no, FreeBSD is the correctest. The other ones would say, no, NixOS is the correctest. And I will say, I don't really care about correct. I'm very comfortable with Debian derivatives, and I'm happy to set things up in a way that's convenient and quick and easy for me to get going. So that's what I'll typically use until I learn something that works better for me. Let's hop over to the application stack. I'm using Elixir, and typically with Elixir, you use the Phoenix web framework. That's what I would do. And with the Phoenix web framework, it's a plenty productive web framework on its own. And with Phoenix Live View, which is sort of this special sauce it brings, I can build very interactive, very well-performing, also real-time style web UIs without bringing in a ton of JavaScript. So I would try to avoid requiring Node or NPM at all. And by default, Phoenix ships with ESBuild these days, which means it doesn't use NPM for its assets pipeline at all. For CSS and that kind of thing, I would typically bring in Tailwind CSS because I find it convenient and easy to use. And there's an Elixir library for bringing in Tailwind without needing Node and NPM. With that, and please note, Tailwind is optional in this stack, but so far I prefer it from not having it. With that, I would say I have full stack development with only Elixir and occasionally some sort of vanilla JavaScript, which is how I would like to keep things. On the database side, SQLite is a very popular subject right now, and it is typically what I would use these days for this type of vertically scaled server setup. It has the potential to perform immensely well on strong hardware, and it removes a lot of database complexity. Now, to make SQLite reliable enough for this type of use, I would bring in the Litestream library by Ben Johnson, which allows you to stream essentially a backup or replicate off to an offsite store of the SQLite data as it's written. That seems like a very good solution to me. Now, I would happily pick up Postgres if I saw the need for particular Postgres features. I like Postgres. And one of the tools I would lose if I don't choose Postgres is Oben, which is a very good worker queue library for Elixir. So Parker Selbert, the creator of Oben, and I have discussed potentially trying to create a sort of Oben Lite, doing Oben on SQLite. It would have limitations probably, but it could be quite cool. But yeah, Oben is great. That's a trade-off. There are other reasons you might want to choose Postgres, and I would definitely use Postgres in many cases. Right now, I'm much more keen on trying to push SQLite further, but both are good choices in my eyes. So why SQLite? Why is that getting popular again all of a sudden? Well, I think the answer is partly it never stopped being popular. It's in tons of devices. Every phone has SQLite. I think every browser has SQLite, so every consumer OS install probably has a few installs of SQLite on it. But the use case for servers, I think SQLite has always been quite capable of being a server-side database. But one thing is, I think the Litestream library is actually important here. It just allows you to run SQLite as a production database with more confidence in sort of backup strategies. And then there's just a yearning for going back to simpler things. Tech is constantly getting more complex, so sometimes we try to go back to basics and simplify. SQLite is fundamentally simple. It really does some complex things, but all in all, it's a database that lives in a file. And that has an operational simplicity that's hard to beat. And with current levels of NVMe storage, it's just blazingly fast, and you can push it to what I expect is fairly absurd levels of scale. And at the point where you start to saturate a set of fast NVMe drives, you either have a successful service or product, or you have a really bad business model. because you're just draining away database performance. You probably have the problem of success at that point. And if you at some point need to switch it out, I mean, it's a SQL database. They're not that different. I think it can be a very good starting choice. It's not for everything, but I'm really, really keen on seeing how far I can push SQLite in different circumstances. Let's return to the GDPR, or at least to customer data for a little bit. So if your product or your business idea has clearly delineated customers, where either their data is not supposed to mix, or there's no point in mixing them, or if you have to respond to legislation such as the GDPR, it can be very, very easy and very, very cost effective with something like SQLite to run a single database per customer. You'll definitely need some kind of central database as well to keep track of which customers you actually have. But it vastly simplifies things like, oh, we want you to remove all our data, or we want you to export all our data. Here, have the SQLite file. This is yours. That, I think, is a powerful way of doing multi-tenancy and giving each customer their own database. That should also let you scale very far with SQLite, unless you have absolutely ginormous single customers, in which case you're sort of screwed either way. Uploaded files and media deserve a special mention. So I would typically put those on something like an S3 compatible object store. Glacius offers one. Hetzner has some storage box stuff that I haven't dug into far enough, but I believe that could sort of serve that purpose. But there's a few reasons S3 style solutions are quite nice. For one, if it's the right fit, they can be the origin for your CDN. And if you're serving a lot of media, you probably want a CDN, and you probably want to buy a CDN service rather than try to do it on your own. And also, in many cases, you want your files to live separately and more redundantly. And you have been in this situation. You don't want the situation where you have to keep growing a set of disks inside a server where you store your files. If you're starting to push past the multiple terabytes, it can get messy. So if you expect to store a lot of files and media, I would look at something like an S3 compatible object store, because in the long term, it just holds up very well. Now for uploaded files and media, I would typically not just store them on that server, because even if you shove a ton of drives in it, the risk is that you outgrow the storage in the physical server. And file storage or object storage is pretty reasonable to scale across multiple nodes. And most of these S3 style services do that for you. So I would typically pay for one of those. Glacius has one. I believe Hetzner has storage boxes that can fill that role. It's also very convenient if you need to place a CDN in front of it, which you might do if you are serving a lot of media. So that's typically how I would handle file uploads and media, unless that was sort of a niche part of the product. If it's a very small amount of files and media, yeah, hard drives might work. Depends on what kind of scale you expect. For deployment, I would use an Elixir Erlang release using the normal mix release tooling from Elixir. I might also include a Docker file. And the reason I'd use Docker is to have the possibility of building for a Linux server on a Mac. I don't typically want a container as the output artifact, and I don't particularly enjoy deploying containers. So I would ideally produce the tarball instead and get that mix release to put on the server. And if you want to do that on a Mac, you need to have some Linux in between, which Docker can help you with. I would also set up a small shell script to run any checks I want. So tests, credo. If I'm doing dialyzer, mix compile warnings as errors is usually in there. And I usually also set up a simple bash script for the entire build process so that the steps necessary are encoded somewhere and automated to a very, very tight script. For running the application itself, when on the server, I would probably use systemd. Now, I'm no power user of systemd and I don't have a strong opinion on it, but it is the default way of running services in Ubuntu and I believe Debian as well at this point. And that's what I needed to do. I needed to start the service, and if it dies, restart it. And I believe systemd can do that. So I would use it because it's already there and try to avoid introducing additional software. I've used Python-based program called Supervisor in the past, just out of habit, and that also works. But yeah, I would typically use systemd. So additional infrastructure or additional applications, additional software that helps everything run smoothly, or that's maybe even necessary for things to run. When I used to build and run Python applications, I usually used Gunicorn for my application server. And that's not intended to be exposed directly to clients. It's supposed to sit behind a reverse proxy such as Nginx that can sort of protect it from abuse essentially. And with Elixir and the included web servers, you don't really need that. It performs fine without Nginx. Sometimes Nginx is even sort of a performance hindrance unless it's configured correctly. If I want to do zero downtime deployments, I would typically use Nginx or high availability proxy to give something that sits in front of my application so I can switch which application traffic goes to without bringing down the port. I am exploring options for doing this without them. I'll have to ask you to keep an eye on the channel and the blog to see if I actually get anywhere with that. But my hope is to sort of reduce the footprint and then reduce the number of things needed as much as possible. Many applications in many other languages use Redis for caching. Redis is fun. Redis is fantastic. We don't need Redis typically for Elixir applications. It's very easy to do whatever caching you want in the application itself, and often you don't need it. So I would probably not add a cache unless I had very good reason to. To get SSL, if I'm using Nginx, I can let Nginx do the termination, and in that case I would do certbot, but more likely I would use Site Encrypt, which is an Elixir library that embeds this whole solution for asking for an SSL certificate via Let's Encrypt and performing the challenges and installing the certificate for you. And I think it's a delightful library for keeping up this idea of pulling everything into your application, so you need fewer and fewer things outside of your application to rely on for running your application. So Site Encrypt, really cool, gets you automated SSL certificates. So how do we get it onto the server, and how do we get the server set up correctly? For that, I don't have a particular favorite tool. As I mentioned, I'm unlikely to be using container images because I don't find Docker all that convenient itself. Where I see it have an advantage is for things that need that sort of common interface of the container to conveniently deploy. But that's for much sort of larger and more abstracted infrastructure. And as you might have gathered, I try to keep things very simple, quite lean, and I'd like to understand every brick in the stack if I can. Right here and now, I would probably use Ansible for setting up the server and getting the application code onto the server, stopping the old one, starting the new one, that kind of thing. I've used it in the past. It has worked well for me. I'm not thrilled with it. One thing, it's built in Python. I remember it being slow for certain types of use. It's complicated. There's lots of YAML, but I also know that if I do it via SSH and bash, I typically cut corners, or I get something that ends up being somewhat clunky to operate. And Ansible does file down some of the rougher edges and provide some really nice conveniences. So currently that's my best bet. If you have an idea about something that you think would fit sort of my ideals, do chime in the comments or via email or via Twitter, because I do want better options. But it's not something I've seen, something that's clearly a better alternative than Ansible for a fairly simple deployment procedure. The important part is that we've codified the steps for deploying the software. And if we've done that, we are ready to put it into CI and continuous deployment. And for that, I would typically just use whatever my Git provider has. I'm not a big fan of GitHub Actions, but it's fine, it works. And GitLab CI, I think that was actually more convenient to use than GitHub Actions, but both work fine. They will do the job. It's going to be convenient. Now, there's always more to it when it comes to production. So we have things like logging, observability, metrics that we need to care about. And I haven't spent a lot of time doing that recently. What I would look at first at this point is Prometheus, Grafana, and related products. And I would hassle Alex Koutmos, the creator of Promx and a good friend, to tell me what I should be doing, honestly. With that foundation in place, there's still some things that we probably want for a production application, such as observability, metrics, logging, that kind of thing. I don't have a lot of strong opinions on what to choose there right now. They're often pricey. There's often a pricey SaaS that will give a good result. Like I've had good luck with New Relic, but it's costly. What I would start with is probably Promx by Alex Koutmos, which is a good library for working with Grafana and Prometheus. And I would hassle Alex, who's a friend of mine, to help me set it up in a good way and solve my problems for me. But even if you don't have direct access to Alex on a regular basis, I would still suggest checking Promx out because it's a really good library. It's very well built out and he provides a lot for free in that library. So try it. Now, ideally, with a deployment pipeline up and running, a beefy and affordable server running our massively concurrent runtime with a very, very fast database on top of some blazing fast storage, we should have everything we need to just hack away at our Elixir code and occasionally write some vanilla JavaScript when we're feeling naughty. And that's the way I like it. Now you know what I would use at this moment in time to build a SaaS product. If you think I'm wrong, I'd appreciate it if you tell me how and why in the comments. If you think I'm absolutely right, I think you should like this video. I think you should use the comments to tell me I'm pretty. And if you are looking for Elixir work, I would suggest you check out the companies that are sponsoring my work with these videos and all the things I put out. They are looking to hire Elixir developers. Their job postings are in the jobs section of the website, or you can find them in the description. If you are with a company or run a company that should be hiring Elixir developers and could benefit from my help, feel free to reach out. There's more information in the description. As always, thanks for watching and stay curious out there.